Hey guys, so go ahead and use this video to check your answers. So problem number one, this is what you should have done. It says solve for the missing side here, and they give us this question mark. So again, let's go ahead and set up a proportion, play a matching game, what side corresponds to which side, and then let's set that equal to another side that we can go ahead and match up. So if I'm taking a look at this bottom side of the second figure here, right, who is it corresponding to? Well, it's matching the bottom side of the first one. That's just going to go ahead and help me write um, my first fraction, my first ratio. And instead of this question mark, I'm actually going to use the letter x, right? Then use the variable instead of a question mark. So I'm going to write my first fraction here. I'm going to say 30 over x, right? I'm trying to use the left triangle, or sorry, the left figure first, and then the right one. So I'm going to say 30 over x is equal to, and again, play your matching game, play your matching game. This left side, if I tried matching it up, right, there's nothing there on the right figure. So this time I actually have to use 42 here. And that's corresponding with 35. So that's going to be my second fraction. I'm going to say 42 over 35. It's just a matter of can we cross multiply and solve. 42 times x, if I cross multiply this direction first, 42 times x is just 42x, which is equal to 30 times 35. I don't know that off the top of my head. So I'm going to use my calculator. 30 times 35 gives me 1,050. All right, last thing we're going to do here is we're just going to go ahead and divide both sides by 42. Okay, what's 1,050 divided by 42? Let's see if this divides nicely. It actually does. X is equal to 25. So the missing side down there, that missing question mark, that measures 25 units. Okay, problem number two. Again, same deal, same deal. So it says solve for x. I notice that x is down here on the first triangle. So who does that side correspond to? The bottom side of the second triangle. So I'm going to say x plus 6 is matching up with 10. Let's go ahead and write our first ratio, our first fraction. X plus 6 over 10. If I can change colors here so it's a little bit easier to follow, is equal to, and again, play your matching game, whichever side you'd like to choose. This time you actually know both of them. So I'll use the left one. Instead of using 12, I don't want to use a bigger number. I'm trying to use the smaller numbers here. I'm going to use 12. Well, that's corresponding to, sorry, I'm going to use 9. 9 is corresponding to the left side over here, which is 6. So because I said x plus 6 over 10, I better follow that same order. I'm going to use 9 over 6. All right, let's go through and cross multiply. 9 times 10 gives me 90. And that's equal to, be careful when you cross multiply the other way because you're going to actually have to multiply twice. 6 times x is 6x, and then 6 times 6 gives you positive 36. All right, we have a two-step equation. All right, so what are we going to do next? We're going to go ahead and subtract 36 from both sides. Minus 36 minus 36. 90 minus 36 gives me 54. 54 is equal to 6x. If I go ahead and I divide both sides by 6, divide by 6. Why is my pen not working? Sorry, give me one second. If I go ahead and I divide both sides by 6, okay, 54 divided by 6 is going to give us 9. And then 6 divided by 6 cancels out just to give us x. So there we have it. 9 is equal to x. All right, problem number 2. So this time I have two triangles, but they're actually overlapping. So my first job is going to be to tear them apart, right? So let me take a look at two figures, just like I was in the last one, but let's do that by tearing it apart. There's a smaller triangle, and then of course there's a much larger triangle. So let's take a look at the smaller triangle. Okay, let's label everything that we know from that smaller triangle. The bottom side there measures 12, and then the right-hand side measures 9. Okay, and that's all I know about the small triangle. Now let's take a look at the much bigger triangle. Let me highlight that, the entire triangle, the bigger one, right? The much bigger one. And instead of this question mark, I'm actually going to put an X there. That's what I'm trying to find, that missing link. But again, I'm going to use a variable instead of that question mark, right? It's a lot more appropriate to use a variable. All right, so let's take a look at the much bigger triangle, and let's label everything that we know. If I take a look at the right side, and I'm trying to figure out this distance here. The right hand side, it's not just 12, it's not just 9. I have to add both of this together. 12 plus 9 is going to give us 21. Okay, same thing for the bottom. I have to go here and I have to combine both of these little smaller lengths, x and 12. I have to combine those together by adding them. X plus 12, well, I really can't combine them, so I'm going to leave it as x plus 12. That's okay, that's okay. Let's go through and set up our proportion. All right, let's go ahead and play that matching game. If I use the bottom side of the smaller triangle, 12, I'm going to set that over, well, the bottom side of the bigger one, which is x plus 12. And this is equal to, if I use the right-hand side of the smaller one, I'll say 9 over the right-hand side of the bigger one, which is 21. All right, it's just a matter of going through now and cross-multiplying and solving this multi-step equation. So be careful here. When I multiply diagonally this way, I'm going to multiply twice here because there's two different terms. I'm going to say 9 times x first is 9x, and then when we multiply 9 times 12, that's going to give me 108. So don't forget to multiply. If there's two things on the bottom, two terms, don't forget to multiply twice. And this is going to equal, made sure I have my calculator out for this one, right? 12 times 21, that gives me 252. All right, it's a two-step equation. Let's go ahead and subtract 108 from both sides. Minus 108, minus 108, minus 108. I get 9x is equal to 144. All right, now again, the last thing we do here is just simply go ahead and divide. If I divide both sides by 9, 144 divided by 9, x is equal to what? That's going to give me 16, right? And that was the missing side here. The missing side length was 16. All right, problem number 4, same thing. I have two triangles that I want to make sure that I split apart. I have the much smaller one that's sitting kind of up above here on the top left. So let me redraw that. All right, something just very quick. Doesn't have to be exact. I do know that kind of that top side there measures 9. And I know that the left side over here measures 12. And that's as much as I know about that first smaller triangle. Okay, we're going to do the same thing that we did on the last one. Now we're going to create a bigger one. Let's go ahead and split it apart. Try to make it just slightly bigger, right? So I don't take up too much room and we still get the idea. Well, the top side up here, it's not just 9, it's not just 3. You have to take both of those distances and add them together to get the full length. Well, 9 plus 3 is going to give you 12. Same thing over here with the left side, right? You're trying to use not just 12, but also that x plus 1. You're going to take both of those smaller pieces, and if you add them together, it's like, well, how do you add 12 and x plus 1? Well, let me write that side by side. X plus 1 plus 12, you can combine the 1 and the 12 to give us 13. This would just be x plus 13. That's what that left side over here is going to measure, x plus 13. Okay, let's go through and set up our proportion. Just play the matching game, I'm going to use the top sides here. 9 over 12. Those are the corresponding sides. Those are the sides that match up. So let me write 9 over 12 is equal to, and I'm going to compare the left side over here, 12 over x plus 13. All right, we're going to go through and cross multiply and work this out. 12 times 12 is 144. And this is equal to, when you multiply the other way diagonally, cross multiply here, you're multiplying twice. 9 times x is 9x, and then 9 times 13, I don't know that off the top of my head. 9 times 13, that gives me 117. All right, if I go ahead and subtract 117 from both sides, okay, what is that going to give me? 27 is equal to just 9x. If I just divide both sides by 9 here, I get 27 divided by 9, which is just 3. X is equal to 3, or 3 is equal to x. All right, we have one more problem here. It says determine whether the triangles are similar. If so, finish the similarity statement. So let's go through and compare, and try to match these sides up. So right here, what I'm trying to do is, let's see, if I compare this, what looks to be like the hypotenuse, right? What looks to be, so this is kind of that 90-degree corner. I'm going to assume there's a 90-degree corner there, right? Try to kind of use that to my advantage. So if I do the same thing with the other one, there it is. All right, so those are the sides that are corresponding. Those are the sides that are matching, right? If we're trying to eyeball it, see if these are actually similar, those are the sides that I want to compare. So I'm going to say 50 over 120 is equal to, well, let's find a different one. I'm going to use this top side right here, which is 25. Looks to be comparable to 60 here. So I'm going to say 25 over 60. And then, of course, the last side here, which is 45 over 108. Okay, so that's my ratio. Now I just want to go through and simplify these ratios as much as I can, by as much as I can. So for this first one, let's see. For this first one, looks like I can simplify top and bottom by 10. Okay, I think I can divide top and bottom by 10. That should probably be the biggest thing. So 50 divided by 10 gives me 5. And again, you want to simplify as much as possible, So 50 divided by 10 is 5. 120 divided by 10 is 12. And that looks about right. I can't simplify that fraction any further. 5 over 12. Let me try the same thing with the next one, 25 and 60. What's the biggest thing I can divide them by? I'm thinking right now 5. If it doesn't work, I'll try something bigger. So 25 divided by 5 is 5. 60 divided by 5 is 12. So far, so good. Let's try it one more time. What about 45 and 108? I'm going to try 9. I'm thinking, hey, I hope 108 I can divide it by 9. I think so. So what is 45 divided by 9? That gives us 5. What is 108 divided by 9? That gives us 12. And take a look. Once you simplified all your ratios, all your fractions, all the way down to its smallest possible form, I got 5 over 12 equals 5 over 12 equals 5 over 12. These ratios are all equal to each other. So yes, that is how you prove that, yes, these are actually similar triangles. Now that we know that they are similar, let's again, go back. Let's go ahead and play that matching game. Let's go through and play that matching game so that we can write our similarity statement. We don't want to just prove that they're similar. We want to make sure that we tell our audience, hey, this side matches with this side. This angle matches with this angle. So take a look at the letter that they started off with, T. Here's T. Take a look. That's where the red and the purple were meeting up together for that angle. So the red and the purple over here would be L. Triangle L. Okay, the next letter that they use is S. Well, where's S? It's where the red and the green meet. So the red and the green meet here, which is M. And then, of course, the last one here is R, where the green and the purple meet. Where the green and the purple meet would be N. That is our similarity statement there. Triangle TSR is similar to triangle LMN, and the order is very, very important. If you wrote those backwards or in a different form, it would be an incorrect similarity statement. So there you have it.